All right, welcome to part 2, the sequel to the Unit 8 review for 5th grade math expressions. And let's do some problem solving together. Here we have a situation where Dr. Florence needs 25 grams of salt for each student to do an experiment. I think it's important to notice that's for each student. She has 1 2/10 of kilograms of salt on hand, and she has 128 students. And we need to know how much more salt is she going to need to have enough for everybody. I noticed right away when it says how much more salt, it doesn't tell us what unit. So it sounds like I can either figure out how many more grams of salt or how many more kilograms of salt I'm going to need. I think I'm going to go with grams. So if that's the case, I need to make sure that all the numbers I'm working with are grams. So first off, what is she going to need total? If she needs 25 grams per student and she has 128 students, then I'm going to need to do a little bit of multiplication to find out how much in total she's going to have to be ready for her experiments. And I'm just going to use the shortcut algorithm here. And it looks like she's going to need 3,200 grams to be able to complete the work, right? So I'm going to put that up here. And she has some of that, and I need to figure out, well, how many grams does she already have before I can know how much more she's going to need. Well, I know she has 1.2 kilograms, but what I have to do is figure out how many grams that is going to be. So to figure that out, I need to go from kilograms to grams. Now I know that 1 kilogram equals 1,000 grams. So mathematically, when I go from kilograms to grams, go from 1 to 1,000, that means I'm multiplying by 1,000. So I need to multiply 1.2 times 1,000. Now to do that, I can use a calculator, or I can do some kind of longhand thing, or I can use my knowledge of place value and say, okay, well, if I've got 1.2, then, and I multiply by 1,000, that means, actually let me move my, I don't want to move the whole thing, but it looks like it's not going to let me break it apart. Let me try another way. Thank you, technology. Let me try another way. If I take that 1.2 and I want to multiply it by 1,000, it means that I can take each of these times 10, times 10, times 10. I can move it 3 place values over. So that 1 is going to go from the ones place times 10, tens place times tens, 100 times 10, thousands. So I'm going to really have 1,000, and that means I'm going to be doing the same kind of times 10 times 10 times 10, which is times 1,000, and that's going to move my 2 in the tens place to the hundreds, and I'm going to need some placeholders to show no tens, no ones in this number. So 1.2 kilograms is 1,200 grams. So I need 3,200 grams. I have, or more appropriately, Dr. Florence has 1,200. That means that 2,000 more grams are going to be needed for her to have enough salt for all of her students. If I went with kilograms, that would be 2 kilograms. Either way, it's going to work. You just have to pick one unit or the other and not try to work in both. At least that's my opinion. Okay, at another piece. I have these out of order, so if you happen to be looking at the math expressions work, then this is item 16. I think it might be part D. There are 4 shapes that you have to classify. And they've asked us to circle every classification that fits the shape. So when I look at this shape, there are some things I notice. The little tick marks tell me all 4 sides are congruent, so they are the same length. The little squares tell me that all the angles are congruent. They are all right angles. I know that this is a polygon because it is a closed figure with line segments, no intersecting lines. I know this is a parallelogram because to be a parallelogram, it has to be a polygon with 4 sides that has opposite sides parallel, and the opposite sides on this figure are parallel. I know this is a rectangle. Why, you say? I know it's a rectangle because a rectangle is a parallelogram that has 4 right angles, and this is a parallelogram with 4 right angles. I know this shape is a regular polygon because a regular polygon has congruent sides and congruent angles. Congruent, remember, same size, same shape, same size, same size, same shape. I know this is a closed figure because it doesn't have any gaps between the line segments. And I know that this is not concave because if it were concave, we could find 2 points inside the figure that when we drew a line between them would cross some of the lines in the figure itself. And that's not the case here. So here we have a polygon that's also a parallelogram, that's also a rectangle, that's also a regular polygon, that's also a closed shape or figure. The way that I went through that, hopefully you paid attention, you saw I looked at each word and said, why is it this? Why is it not this? So you want to go through the reasoning on each term before you make a decision. That's better strategy than guessing. Trust me. All right. Back to problem solving. And now we're going to talk volume. A cargo space of a railroad boxcar measures 42 feet long by 9 feet wide by 11 feet tall. Find the volume of the freight that can be placed in the boxcar. I think the easiest way to do this is by using the formula for volume of a rectangular prism, which is what a railroad boxcar is, length times width times height. In this case, we have a length of 42 feet, a width of 9 feet, and a height of 11 feet. In terms of multiplication, I think that for me, the fastest thing to do is to multiply 9 times 11 for 99, and then use whatever multiplication strategy you prefer to multiply that out. I'll use a shortcut traditional algorithm for this. And I don't have a whole lot to say about that because I'm worried if I talk when I'm trying to multiply, I'll mess something up. I think we did all right here so far, though. And I'm getting a volume of 4,158. Oh, I need to make some room because the most important part is coming up. 1,458 cubic feet. And I can write that like this, or I can write it CU for cubic and FT for feet, like that. Why is that important? Because if we're studying volume, then to show that we understand volume, we have to designate the volume correctly. We're not being assessed on multiplication here. We're being assessed on our understanding of volume. We have to communicate that understanding in a way that shows, yes, I know this is volume, and not just naked numbers multiplication. All right. highway that has a width of 1/3 of a foot and it covers an area of 900 square feet. So this sounds like a two-dimensional problem. It's got a width of 1/3 of a foot. I love to, personally, I love to draw to help me visualize. And it has an area of 900 square feet. What we don't know is the length. Again, we can use a formula here. We know that the formula for the area of a rectangle is length times width because it's only two-dimensional. We're only measuring in square units, like the square feet we see here. Now, I already know the area. It's 900. And I know the width, but I don't know the length. So some number times 1/3 is going to equal 900. Well, I got to tell you, that is going to be a big number, at least bigger than the numbers we have here. Now, typically, if we're missing a factor, we use division. We would divide the area by one of the factors. And that's exactly what we're going to want to do here. We want to take that area, and if we divide it by 1/3, we can find the length. Well, how do you do that? Well, remember, when we're dividing with a fraction, we use an inverse operation, which is multiplication, and we invert the second factor. So 1/3 becomes 3 whole, or 3/1 if you prefer. Now, here's the good news. This just became mental math. 9 times 3 is 27, and 27 times 100 is 2,700. Now, I want you to think. This is where things can tend to go south for folks. We're saying that this here, this line, this length is 2,700. That's one dimension. How long? So what unit will we use? Not square feet. Nope. Because we've already got the area. We already figured out the square units. All we're looking at is one dimension. How long is this painted line? So it's going to be 2,700 feet. Just like the width is in feet, the length will be. One dimension is what we're measuring. Right. Well,